Thanks for watching my video. It's more intended as a bit of a workflow than it is a tutorial as such. Just making use of a couple of programs here, Diptrace and also CopperCam. Diptrace I've used a lot more than CopperCam. I've used Diptrace also to export files to send out to proper printed circuit board manufacture houses. Just some pads here. This particular project is a breakout board for some cabling for a 3D printer project. Here I'm manually routing the traces. Diptrace has got an auto router, does work pretty well. I actually use the auto router to place a board outline. I find it does a nicer symmetric job of it than I would have done by hand. Here I am exporting out the files from it. Just being a single layer board, I only need a top file and a board outline. This board export there that I did was actually incorrect. Also, you need a file for the drills. Here we go, bring it into CopperCam. Both Diptrace and CopperCam are commercial programs, but in terms of the alternatives, the paid alternatives, I've found them both to be pretty reasonable priced. I've played around with some of the free ones and not had a great deal of success. That's not to say that there's not some good free ones out there. This is just setting up for the toolpaths, how many contours, etc. As things progress on with this, I got my process dialed in a lot better. Actually found some settings that I didn't find initially that gave me a lot more flexibility, and I was a lot more happy in the end with it. To be honest, things are a little bit of a shambles there. By my last printed circuit boards though, and this run, I was much happier with it. It's just the G-code there. Here it is out on my CNC. This is just a desktop one, 600 by 600 work area. It's a 2.2 kilowatt water cooled spindle. It's a dust shoe there. It's not particularly effective because it's missing its brushes. We'll replace that at some point. This CNC is pretty decent in terms of hobby grade. It's got proper linear slideways and ball screws, so it's pretty decent compared to a lot of the alternatives. I was quite lucky, I picked it up second hand, having it had a very limited use. This is one of my favourite work holding methods for things that don't require a great deal of hold down force. Very convenient. You place tape on the work surface and tape on the back of the thing to be machined. Then you just use super glue to glue the two pieces of tape together. Then once it's machined, it's just as simple as peeling off the tape. Obviously for something that you are holding down like metal, aluminium or something like that, probably wouldn't provide the holding force, but for this it works perfect. Incidentally, if you were wanting to do some aluminium, I have seen people actually super glue aluminium down before, and that's reasonably successful sometimes. You just need to be aware that super glue is likely to fail if there's much heat generated. In the ideal world you shouldn't be generating a great deal of heat, but we know this can happen. Here we are just doing the isolation routing here. I've done one already. This is using a carbide V-carve bit. Can't remember the angle on it, but it's got a 0.2mm tip. I do quite a number of passes here, probably more than I need to in fairness. this starts off at real time, and then I speed this up to 5 times. There you go, just speed up to 5 speed. I don't tend to do any surface mount stuff, so I can't speak to its accuracy on tiny traces. Here I'm testing for isolation between the traces, no problems at all. I'm cutting deeper than I need to, it probably should be in fairness. I'm cutting down to about 1/2 millimeter deep. This program defaults to 1/4 millimeter. They call it a corn cob, I believe, but that I just put on there. It's used for cutting the printed circuit board out. All these tools that I'm using here are 1/8 inch diameter. Here I am doing a tool change onto one of the drills. Rather than using a different size drill for mounting holes and for my wires, I actually just use the single one and then open up the mounting holes with the battery drill after. The mounting holes are a little bit more forgiving as far as their size, and the small drill provides an accurate pilot anyway. This is just a El Cheapo sort of jowl pendant I've got in my hand. It didn't come with the CNC, but it's been worth its weight in gold. A lot easier than just using arrow keys. There I am, zeroing out the drill onto the top of the printed circuit board. It's not necessary to do so, but I've got my drilling going down to 2 millimeters deep. In theory, you'd only need to go to the 1.5 millimeters deep of the printed circuit board, but time and time again I've had issues with it not penetrating quite through, so better off to go down to the 2 millimeters, make sure it goes right through. And here we go, doing the cutout pass. Just so I don't apply any tearaway force, what I'm doing here is going through in 1/2 millimeter at a time, and then going down to a maximum depth of 1.2 only. You'll see at the end I just use a pair of snips to cut it out, and then some sandpaper to tidy it up. I probably would have got away with actually taking it all the way through with this corn cob cutter, and I may well do so in the future. It saves another step of having to do the manual tidy up. Just when you go through to your breakthrough of any machining on the other side, can be quite a bit of forces. And if it is going to pull away, that'll be when it does it. Just cutting out. Very, very effective. I suspect if I was to use a normal traditional cutting bit on that, that the cutting edge wouldn't last particularly long. Obviously the fiberglass dust from this cutting out this laminate of the circuit board is pretty aggressive, quite abrasive. Just taking off the masking tape. As you can see, I had one zeroing whoopsie there. cutting out the boards with the snips. There you go, and I've just cut them out, sanded them, and opened up the mounting holes. Pretty happy with the results. Thanks for watching. Hope you enjoyed and perhaps learnt something. Have a good day.